Hey guys, on Friday you worked to add and subtract numbers in scientific notation, but I had you expanding out the coefficients and putting all those numbers back into standard notation, which is kind of annoying because it creates a lot of extra steps. So I want to show you another way that you can do it by moving your decimal. Please take a minute to copy down add and subtract in scientific notation, draw your line, and write remember Lars. Pause the video now. What Lars means is when we move the decimal left, we're going to add to the exponent. When we move the decimal right, you're going to subtract. My pen is your pen. Please make sure this is what it says in your notes. Pause the video if you need to. Please copy down example 1 to the left of the line and this example to the right. Again, pause if you need to. Instead of pulling out our coefficients and turning these numbers into standard notation, the way that you can use Lars to help you solve these problems with addition and subtraction is first take a look at your exponents. They're different. I have 3 and I have 4. I'm not allowed to add my coefficients until these exponents are the same. So I always keep the greater exponent, keep the 4. So this number is fine. I don't have to do anything to it. 7.1 times 10 to the 4th. But then this number, what I need to do is I need to increase my exponent by 1, because 3 plus 1 is 4. And remember Lars, when I move my decimal left, that's when I can add to my exponent. So I need to grab this decimal and move it 1 step left. So the number I'm working with is 0.35 times 10 to the 4th plus 7.1 times 10 to the 4th. Now that my coefficients are the same, I can add them. 7.1 times 0.35, and remember when you add with decimals, plus 7.1 plus 0.35, and when you add with decimals you need to line up your decimals and fill in zeros. Now I can add 5, 4, bring my decimal straight down, 7. My new coefficient is 7 and 45/100ths. However, I was adding in scientific notation. I need to keep my problem in scientific notation. So I rewrite times 10, and because my exponents are the same, I keep my exponent. That's a 4. This number is in scientific notation because my coefficient is in between 1 and 10, so I'm good. Let's do another one. Please copy down example 2 and this problem. Pause the video if you need to. The first thing I'm going to do is I'm going to look at my exponents to see if they're the same. I have a 3, I have a 2. They're not the same, so I am going to keep my greater exponent, which is the 3, so I don't need to do anything to this number. 7 times 10 to the 3rd minus, and now this one, my exponent is a 2, I want to make it a 3, so I'm going to add 1. Remember Lars. If I want to add, I need to move my decimal to the left. I'm adding 1, so I move left 1 time. This becomes 0.325 times 10 to the 3rd. Now that my exponents are the same, I can just subtract out my coefficients. Remember that this is a whole number 7, so my invisible decimal is right here. When I line these numbers up to subtract, I need to line up my decimals and fill in zeros anywhere I don't have zeros. I can't do 0 minus 5. I go next door. I can't regroup. I can't regroup. I have to go all the way over to this 7. I'm going to rewrite it as a 6, and that means now I have 10 tenths. I can't take 5 away from 0. I can't regroup here, so I need to go over here, take away one of these tenths. This becomes a 9, and now I have 10 hundredths. I still can't do 0 minus 5, but I can regroup this, borrow from here, this becomes a 9, and now I have 10 thousandths. 10 minus 5 is 5, 9 minus 2 is 7, 9 minus 3 is 6, bring my decimal straight down, 6 minus 0 is 6. This is a great coefficient because it's between 1 and 10, but I need to get this number back in scientific notation. So I'm going to rewrite it times 10, my exponent is a 3, 6, and 675 thousandths times 10 to the third is my final answer. Let's do one more, and it's you. Please write example 3 and this problem. Pause if you need to. First thing I'm going to do is look at my exponents. They're different, so I can't add my coefficients yet. I want to keep my greater exponent, which is a 6. Now let's look at my other exponent. It's a 5. To get from 5 to 6, I add 1. And remember Lars, I have to move my decimal left to add to my exponent. So I'm going to grab my decimal and move it once to the left and drop it off. That means now my problem is 141 thousandths times 10 to the 6th plus 3 times 10 to the 6th. My pen is your pen. Pause if you need to. Now that my exponents are the same, I can just add my coefficients. My invisible decimal here is behind the 3, so I have 0.141 plus 3.000. Fill in my zeros. Bring my decimal straight down. My new coefficient is 3 and 141 thousandths. It's a good coefficient because it's between 1 and 10. I'm going to rewrite times 10 to the 6th, and I'm done. The last thing I want to show you is what do you do if your exponents are the same? This is actually super easy because this is what we've been doing all along. If I have 5 times 10 to the third plus 2.8 times 10 to the third, the first thing I was asking you to do was look at your exponents and keep the greater one. These exponents are both 3's, so we actually don't have to do anything with our decimal. If the exponents are the same, just add your coefficients. 5.0 plus 2.8 equals 7.8 times 10. My exponent is a 3. Your turn to practice.